Hi, my name is Kaitlynn Leary, and this is the transmitter schematic for my circuit's final project. So first up here, I have my microphone input, so this is symbolizing my microphone. Then I have a voltage divider right here, which is used as a volume control. So the resistor up here is fixed, and this resistor in my circuit is actually a potentiometer. So as I change the resistance of this resistor, I could change the volume because I could change how much voltage was dropping. Okay, so then next, the signal goes into a high-pass filter. Then after the high-pass filter, it goes into an op-amp, and this op-amp is a amplifying op-amp. So it takes the signal, and it has made it have a really big gain. So the feedback resistor up here is 450 kiloohms. So really big gain with that because the signal by itself wasn't very large. And then it goes through another filter. So I have a capacitor here to block like any DC current signal going through, because we're only interested in the AC signal. And then down here, this symbolizes my aux input. So I had an audio jack from my phone that plugged directly into the circuit. So I plugged it directly into the circuit. And then over here, this is my summation setup. So the two signals, the microphone signal and the aux signal, are added. So they're added together. So this is my summation op-amp to add both of them together. And then after that, again, I have another capacitor to block the DC current, just letting the AC current going through. And then over here, this is my DC offset setup. So I've got an inductor, and after changing around the values, I got it to be offset to like 4.5 volts, so the laser was continuously on and bright enough where it could be seen and like from 15 feet away and transmit from 15 feet away. And then this over here is my laser, and in series with my laser is a 220 ohm resistor, and this resistor was used to limit how much current was going through the laser, so the laser didn't get burnt out. Hi, my name is Kaitlynn Leary, and this is the receiver schematic setup for my final circuits project. So over here, this is symbolizing my photodiode. So as the signal gets transmitted through the laser, it goes to the photodiode, and the voltage is changing because photodiode changes the current. And then it goes through a filter. And then after the filter, this is just filtering out some noise, it goes and gets amplified. So I found that the signal coming through was very weak, so I had two op-amps to amplify the signal, and they each had a feedback resistor of 470 kiloohms, so really, really, really big gain. So it goes to the first op-amp, goes right to the second op-amp, gets amplified, and then it just goes to over here, which is this resistor symbolizes my speaker. So after the signal gets transmitted, photodiode changes the current, goes through a filter, gets amplified, and then goes to my speaker to play the song.
Wait, is that
Yeah, and it doesn't have the exact same key.
You want me to adjust the volume? No, because I can show you.
Okay, that's okay. But Andrew doesn't have the exact same.
No, I'm going to do that.
Hi, my name is Ottalagana, and I worked with Kaitlynn Leary on this project. We used the same schematics for both of our circuits, so I just wanted to show you a couple videos of my circuit working.
to the most.